Hey everybody, welcome to the PC Perspective Mailbag. This is episode 28. I'm recording this on the 26th. You'll be seeing it on the 27th. If you have questions for us, for me, for Josh, for Alan, whoever, leave them in the comments of this video. Leave them on PCPer.com in the comments section of the post associated with this video, and we'll look through them and pick out some questions that we feel like are that we can answer. They can be about hardware, they can be about the industry, they could be about us, they could be about you, I guess. I don't know. But let's go ahead and jump right into it. This is a question that comes in from Interesting start. Do you guys have any info about the mid-range budget motherboards for Coffee Lake? Did Intel show some 8th gen compatible motherboards at CES? Pairing a Core i5-8400 with a Z370 board is not so cost effective, and building a system now is already quite expensive. Yes, it is. At this point, I don't know of a budget chipset compatible with Coffee Lake. I think it's something you'll probably see the first half of this year. But honestly, I don't know when that will be. I agree that pairing a Core i5-8400 with somewhat more expensive Z series platform is maybe not the best idea, and something that kind of devalues the value of the i5-8400 in the market quite a bit. You can still find boards for the low hundreds range for that, but if you're looking for something sub $100, which I think is very possible depending on the type of system you're building, and you're targeting the 8400 as your processor of choice, that you might be looking for. And also, yes, you are correct that building a system is already quite expensive thanks to memory and graphics cards. There any way you can find to save money, I think would be beneficial in most gamers' eyes. I assume that we'll see lower cost, either like B series type drive or motherboards, but it also wouldn't surprise me if the rumored Z390 chipset happens, if maybe we wait until we see those and we'll see more mainstream products ship out. Davey S wants to know, how does Bitlocker disk encryption affect performance? Is there a performance hit during use, or does everything just get decrypted at the Windows login, then performance thereafter remains the same? So I asked Alan about this, and the answer is that Bitlocker, there's two different types of disk encryption. There's the kind that happens in hardware on the SSD itself, which a lot of SSDs, if not most new SSDs, support. And then there is the software-based encryption like Bitlocker. And that allows you to use it on any drive, and you set it up after the fact. The interesting thing is the performance hit. Essentially, you do have to do encryption and decryption, the system does, every time it reads or writes to the disk, which would sound like you would have this pretty significant performance hit. However, for the last 3, maybe 4 generations of Intel processors, you do have these AES extensions, instruction set extensions that improve performance dramatically and actually make the performance impact mostly negligible in terms of actual system performance. So if you have a new-ish processor, there should not be any performance hit during use, even though it is in fact doing work every time you're reading and writing to disk. Might be an interesting thought experiment to see how those are affected by, Spectre Meltdown patches and microcode changes. That's a bigger headache and hurdle for a lot of reasons. Interestingly, the encryption method that works at the hardware level, at the SSD level, Alan was explaining that basically all new SSDs do encryption all of the time regardless. It's just whether or not they're using kind of the standard default key, which is handled internally automatically, or if you enable it on the platform itself. Now, the question or the issue is that most consumer like motherboards and systems that you buy, desktop systems or build, don't have that even as an option today, and it's mostly seen in Intel vPro enabled systems or notebook computers if you want to enable it, those types of things. And at that point, that would be like you power on the system, you wake it up from hibernate, you insert a password, and then it boots, and then you insert your Windows password or log in through Windows Hello, whatever you're going to do there. So that seems like it might be a slightly better option, but there just hasn't been a lot of adoption of it recently. Christopher Worthen wants to know, I have a spare 32 gigabyte Optane M.2 laying around. Will using it as a page file location give added benefits? The answer is yes, right? One of the targets for Intel's Optane technology has been this in-between system memory and SSDs, right? It has significantly faster access times and lower latencies, but it's more cost-effective than system memory, especially now. So yes, if you install that in an M.2 slot and it shows up as 32 gig drive and you make it a swap partition for either your application or what have you, you will see some performance benefits over using a traditional SSD for that. However, it's still not better than system memory. So the only time this would actually be useful is if you are actually swapping to disk. So if you only have 16 gigs of memory and you know your Adobe Premiere video projects, go beyond that and hit swap disk, you'll see advantage. However, if you have like 64 gigs of RAM and you're never actually filling it, then that Optane drive won't be utilized in the same way. So, it depends a little bit on if you're configuring this at the Windows level or you're just configuring it as a drive with application level caching. There might be some differences there, but yeah, I think if it's spare, you don't plan on using it for anything, installing, and you have an empty M.2 slot on your board that you can install it on, you could potentially see some performance improvements with it. Jan wants to know, why aren't AMD and NVIDIA ramping up production to meet cryptocurrency demands? In all, miners buying mini cards should be a good thing and should drop the price for us all instead of increasing it. Oh, Jan, to live in your world would be nice. So why aren't AMD and NVIDIA ramping up production? A couple of reasons to that, maybe. One is probably that they have ramped up to some degree, but not enough to offset the Ryzen demand still occurring for cryptocurrency mining purposes. The other reason why they wouldn't ramp up even more is they're trying to mitigate risk of producing a whole bunch of chips that have, a 3 to 6 month lead time before they can, be in the channel, for example, and something happening to the Bitcoin / altcoin cryptocurrency markets that they crash down tremendously, and you are left with a bunch of GPUs of an older generation, assuming that you're working on new products, that now either have to be sold at much more discounted rates, competing with all of the cards that are already out there from miners that might be being resold. And it creates a very complicated stock issue, pricing issue that they don't want to have to deal with, because nobody, despite Bitcoin mining or cryptocurrency mining still being a major topic, nobody's quite sure how long it's going to last. Or is this a forever thing? Is this going to transfer from GPUs to ASICs in the meantime? There's still a lot of question marks. And so they're just basically, they don't want to increase production by 100% and then get stuck with a bunch of inventory. As for your assertion that, if AMD and NVIDIA were suddenly selling twice as many cards, that somehow price would go down, it's not really the case. There's no, AMD and NVIDIA are already hitting the level of bulk build that gets them kind of the lowest possible price they can get from TSMC and Global Foundries and those guys, and from production facilities that are putting the PCBs together. I wouldn't expect, like, if they suddenly sold twice as many and the prices would go down, expected MSRP, even if you balanced supply and demand of mining and gaming with what they are actually producing. I wouldn't expect pricing to actually somehow be minimized significantly because of it. So, sorry. I don't have another answer. Go buy an OEM PC, I guess, or a gaming notebook. Blown Cold 1 wants to know, do you think that a $400 MSRP increase for GPUs accompanied by a $400 rebate would help solve the mining problem, as most manufacturers limit rebates to 1 per address? I think it would help. I think the idea of charging a whole bunch and then rebating it would probably help out tremendously, but it's a complicated thing to do, right? People already hate rebates when they're like $25 because there's the risk. First of all, there's the pain in the butt of having to fill out this paperwork. Obviously, if it's $400, you're going to spend a lot more time and make sure you get it all correct. But there's also like, hey, my rebate was denied for a stupid reason, or I only partially cut off the UPC or whatever it happens to be, people kind of have a distaste for rebates. So suddenly gating $400 of your money behind that rebate as opposed to $20 or $30 behind that rebate, I think might put some people off. It also means that you still have to shell out. If you're buying a $400 car, that means you still have to shell out $800, and you have to wait whatever the processing time is to get that $400 back. So it's still, for I think a large portion of people, would be too high of an initial investment. Even if you thought the total price after rebate would be fair. It's actually interesting, something that Micro Center is being talked about in the this week for selling a GTX 1080 Ti for $1,500. Now they don't have a rebate to get it back down to normal price, but if you go in and you buy a motherboard and memory and a processor and a cooler or some combination of components that they're being overly vague about, they will reduce the price of the graphics card significantly. The idea there being that if you're buying all those other components, then you are you're buying it for the right reasons. You're not buying it for mining, and you're not trying to take advantage of the retail outlet. And then, of course, if you would suddenly try to return the motherboard, processor, memory, and cooler, that you would not the difference to if you tried to basically return it and only buy the GPU, that you would have to pay that difference out of that return. So I think that's an interesting idea. Obviously, it's still irking some people because of the price tag that is associated with it, but there's not a lot of great solutions to this problem out there. I think the rebate one is interesting, but then you'd have to figure out who's going to do it. Is it going to be the resellers? Is it Newegg and Amazon? Is NVIDIA going to work with their partners and do it that way? That's a lot of funding that you need, right? You suddenly have to have a lot of additional funds to work with on that regard. So Austin Strand asks, what is the likelihood of something like a Ryzen R7 2700G or R5 2600G? I'm thinking about home server applications where video output is needed, but a GPU is overkill, discrete GPU is overkill, and the slot could be used for something else like an additional NIC. So I guess Austin's question is more surrounded with, why don't we see higher CPU core counts for the APUs that AMD has announced, right? You like the idea of having a Vega GPU integrated on there because you don't need discrete graphics. However, you would like to have the full performance of a Ryzen 7, 8-core, 16-thread processor, for example. I don't know if the likelihood of that is probably not great for the foreseeable future because of the die size that would create. So keep in mind that AMD has chosen quad-core parts with Vega GPUs to balance die size, cost, and then resulting performance. If you wanted to double the core count, you'd have to increase the die size pretty dramatically, which I don't think is impossible, but is, I think with the Ryzen APU, what they were trying to do right now is kind of balance both, right? It's a 65-watt TDP part that has a quad-core capability, which is good for most people, and a integrated graphics solution that is good for most people. What you're looking for is kind of a more specific part. I like I said, I think it's a good idea, and I would like to see them do something like that. But that's a totally different chip. It's a totally different spin. It's not something they can just modify on the fly and create. I think we're still waiting for next month the release of the AMD APU, and we'll see how well that is received. I think for AMD, it's a win-win, right? They have 50% of the market they haven't been able to address, and now they can. But that 50% of the market tends to err on the side of lower cost, lower power draw processors than higher performance processors. So, yeah, no real answer for you, but I understand the need, and I think they're paying attention to that kind of stuff. Joseph Szewski, I'm trying to pronounce it like Mike Krzyzewski, the Duke basketball head coach, but I don't think that's accurate. Sorry, Joseph. With the continued improvements to GDDR, will HBM ever become necessary for performance advancements in future consumer gaming workloads? Necessary is an interesting word there, because I think with GDDR6 coming, for example, the argument of the bandwidth improvements that HBM provides and HBM2 provides is harder to make a case for, right? So GDDR5X cut the gap between G5 and the first HBM when NVIDIA started using it on its higher-end GTX parts. HBM2 actually didn't improve your memory bandwidth that much in its implementation because it got faster, but they used half as many stacks, so half the bus width. So in general, it wasn't a significant improvement over previous gen. Actually, I think the RX Vegas have less memory bandwidth stock settings than the Fury X, right? So worth noting. GDDR6 will improve bandwidth in that configuration and that platform, I think, pretty dramatically. Again, but the benefits of HBM are not bandwidth only. The benefits of HBM are packaging, right? The fact that it's smaller, takes up less board space. You can see that in the design of the Fury X cards. You can see that in the integration of a Vega Plus HBM2 on Intel's Kaby Lake G processor. And also you have power benefits. Because it is a slower frequency at a wider bus width, it just runs more efficiently. You're getting more performance per watt out of that system. So in mobile configurations, notebooks, the advantages of HBM of space and power are much more important and much more, impactful on a system design than GDDR or than HBM would be for a desktop add-in card, where you have a decent amount of thermal headroom. You've got plenty of space. You don't worry about if the PCB is an inch shorter. It's not a killer design flaw. Not that you can't make interesting products in that. The Nano cards from AMD were that, right? It was an interesting high performance home theater PC small form factor design that allowed you to do interesting things. They teased that for RX Vega, but it never shipped, never came out. So whether or not it ever will seems unlikely at this point. But there are other advantages to HBM other than GDDR or other than just bandwidth. So we'll have to see. Planet Vampire wants to know, will you need to rerun all of your GPU benchmarks after the microcode updates and Meltdown fixes? Seems like if a new GPU is released, the data from the previous runs wouldn't be consistent in games. I'm not saying it's impossible, but it's unlikely that gaming performance will change because of these updates. So, in general, the security patches and microcode updates affect storage performance, networking performance, things that switch between user and kernel mode contexts very often. While obviously gaming does have to access the disk and stuff, it's not as frequently. And when it is happening, it seems to be happening in larger chunks as opposed to small iterative bursts or iterative bits. So I'm not saying that there's no performance difference, but I would guess, my assumption would be that the GPU benchmarks that we have run will have very little change after these updates. Now, that being said, most of our platforms here in the office have been updated. So when the time comes to test a new GPU, we will be taking that into effect, if only because we have no choice but to, if we want to use the latest versions of Windows. But I don't think gaming is going to be one of those targets. If you look at the results that Intel's put out there, and if you look at the results that some websites have put out as well, gaming saw basically zero impact from these updates. Not impossible. There may be edge cases where some games are accessing the hard drive more. Maybe you're streaming in a bunch of content continuously to avoid load times. Maybe that's something that gets affected, but in general, I wouldn't worry too much about that. Lambda Ghost asks, do you think AMD will be able to make a comeback in the graphics card market, or is NVIDIA too far ahead? I don't know. I don't think NVIDIA is too far ahead in the graphics card market, and it really depends on which segment of the graphics card market we're talking about. In the consumer gaming side, RX Vega is not a bad product. It really isn't. It's not as power efficient, and it had some cost concerns when it launched. Obviously, everybody has cost concerns now, but because of the mining availability of parts issue, it really kind of doesn't matter what anybody's performance is. AMD and NVIDIA sell everything that they make. Their partners sell everything that they produce. So it would be, not only would it be almost impossible to measure, but it would be almost useless to measure a change in market share of gaming graphics cards, because I would argue that maybe half of all the gaming graphics cards that are getting put into production are being bought are not being used for gaming. So what does that market share look like? Do we need to separate, gaming market share from mining market share? And then if you do that, how do you even do that for people that are doing a bit of both? For an AMD, where they do have a significant need to come back from, is on the enterprise side, right? Like if you look at machine learning, artificial intelligence, autonomous driving, NVIDIA has been banging that drum for a long time. They've been doing it very efficiently, and they have a humongous lead over not just AMD, but everybody, right? Intel is trying to enter machine learning. You've got Google with Tensor cores. You've got, Tesla wants to do their own autonomous driving chips. There's a lot of competition there. AMD has a distinct advantage over everybody except NVIDIA in that they have a high-performance GPU core and intellectual, portfolio of parts that can be applied to that. But that's probably where they're most concerned at, because that's also where the higher margin is and where the stronger growth is. But I think AMD will be able to, come back in the terms of make very competitive high-end and mainstream graphics cards that will force NVIDIA to answer and do things in a way that they haven't had to do really in the last couple of years. We actually had a question here from Pixelated Donkey, great name, about why do the Meltdown Spectre patches have negative impact to performance. And I think we kind of explained that, right? The patches are basically workarounds to, let's see, for safety reasons, clear out page tables and buffers in the processor when you change between user and kernel context, so that a rogue application trying to access those caches or buffers to try to steal information that they shouldn't have don't have the ability to do that. Now the problem is every time you flush a cache or a buffer or something, when the application returns, then every cache lookup is a miss. So now you have to repopulate all these caches and buffers along the way. So that's where the performance penalty comes into play. And like I said, that happens mostly from workloads we've seen so far: high transaction count, storage, networking, connectivity, those types of things. So not a whole lot for gaming, and not a lot of stuff that is CPU compute dependent, right? So floating point performance, integer performance don't seem to have dramatic impacts there. So that is going to end it for this week. Thanks everybody for sending in your questions. Again, PCPer.com. Go there, read all the stuff. YouTube.com/PCPer is our YouTube channel where you're probably watching this. But leave your questions in the comments below, and leave your questions on PCPer.com in the post associated with this video. And we'll be back with another episode next week, guys. Thanks.